The average value of a function. So imagine that you have a function f of x, and again, simplicity's sake, for simplicity's sake, I assume that f of x is going to be a positive function, that is from a to b. It's positive, it's above the x-axis. Now, this function assumes different values depending on what x is. So, for example, if x is a, the value of the function is going to be f of a. If, let's say, it is x1 here, then the value of the function is going to be f of x1. If x is equal x2, then the value of the function is going to be f of x2. So the value of the function is changing depending on what the input to the function is. And for any different input that you have, you're going to get a different f of x. So when we talk about the average value of the function, we mean what would the value of the function be on average within this range from a to b. And whenever you talk about the average of a finite number of data, then it's very easy to calculate that average. So imagine you have y1, y2, y3, and y4, and you want to find the average of these values. Then you would just add them all up, and you divide that by the number of the data that you have. So in this case, I have 1, 2, 3, 4 pieces of data. I want to add them up and divide by 4. That would give me the average for these numbers. And for this function that I showed here, you have f of a, f of x1, f of x2, f of x4. You can find the average of these values that come out of the function as long as they are a finite number. However, when you're dealing with a function like this, there are infinitely many possibilities because there are infinitely many numbers between a and b. So for any of these numbers that you plug into the function, you get a different value. There are infinitely many of them. How do you find the average of infinitely many numbers? So what we do in this case is we're going to approximate the average. So again, assume that f of x is a positive function that is defined from x equal a to x equal b, and we're trying to find the average value of this function within this range. So what we can do is we can partition from a to b. So let's say we partition that into 4 subintervals, so that this is x0, this is x1, x2, x3, and then b is going to be x4. Then what we can do is we can evaluate what f of x1 is, what f of x2 is, what f of x3 is, and what f of x4 is, and then just divide by the number of these 3 data points that we get from the function. So one approximation for the average value of the function would be f of x1 plus f of x2 all the way to f of xn, assuming that you have n subintervals. You have divided the whole interval from a to b into n subintervals divided by n. That's a good approximation for the average value of the function. And that approximation would be even better if the number of intervals that you have is more and more. Are we good? Any questions so far? So notice that this can be written as 1 over n times f of x1 plus 1 over n times f of x2 all the way to 1 over n times f of xn. And as you can see here, we're doing some simple algebra. What happens if we multiply this expression by b minus a over b minus a. So you agree that b minus a over b minus a is simply 1. So by doing that, we are not changing the value of this expression because b minus a over b minus a is simply 1. However, if I just multiply the b minus a by every term, in other words, if I distribute that, I'm just using this, the fact that a times a over, let's say, c times b1 plus b2 plus b3, if I have something like this, I can write that as 1 over c times ab1 plus ab2 all the way to ab3. Yes, I can do that. That is, I can distribute the a, multiply this by b1, multiply it by b2, multiply it by b3. So this is exactly what's happening here. So the 1 over b minus a stays outside of the square brackets, but the b minus a, you multiply that by 1 over n, you get this. You multiply that by 1 over n in the next term, you get this, and all the way. What is the purpose of that? Notice that what we have here, b minus a over n, is simply the delta x. So when we were learning about the Riemann sum, we learned that delta x is b minus a over n. And then the expression becomes 1 over b minus a times f of x1 delta x all the way to f of xn times delta x. And also, you should recognize that what we have here is actually the Riemann sum. So if I want to write that using the summation notation, that's going to be f of xi times delta x, I from 1 to n. So the approximation is actually 1 over b minus n times the Riemann sum for the average value of the function. And how do we increase the accuracy of this approximation? Because whenever you're dealing with an approximation, the question arises, how can I improve that approximation? And the answer, just like the case of the Riemann sum, is by increasing the number of intervals. So I can just take the limit of this as n approaches infinity to get the average value. So if I do so, I take the limit of this as n approaches infinity, I'm going to get 1 over b minus a times the limit of this Riemann sum. However, we know that the limit of the Riemann sum is actually an area. It's the area under the curve. So if you have this function f of x equals a and x equals b, then the limit of the Riemann sum is denoted by integral from a to b of f of x dx, and we know geometrically it's the area of this region here. So the average value is going to be 1 over b minus a times the limit times the definite integral from a to b f of x dx. So we get this formula here. The average value of the function, suppose f of x is integrable on an interval from a to b, then the average value of f over the interval from a to b is defined by this integral here. It's just 1 over b minus a, that is 1 over the length of the interval from a to b, times the definite integral from a to b of f of x dx, which we know geometrically is the area under f of x above the x-axis between the two vertical lines x equals a and x equals b. Let's look at one example. So it says, find the average value of the function f of x equals root x over the interval from 0 to 4. So this is the function f of x equals root x. So it passes through the point 0, 0, it passes through the point 1, 1. It also passes through the point 4, 2. So if this is 4, then the point here is going to be 2 because the root 4 is 2. And if this is 1, the y value is going to be 1. It also passes through the origin. So f of x is a function like that. Of course, it continues like this forever and it increases to infinity. Now you can see that this function assumes different values depending on what x is. The question is, what is the average value of this function from 0 to 4? We have a formula for that. The average value is going to be, so the average value of f of x within the interval from a to b is going to be 1 over b minus a, integral from a to b, f of x dx. So for this particular problem, it's going to be 1 over 4 minus 0, integral from 0 to 4 of root x dx. And in order to calculate this, we don't have to use the Riemann sum because we know about the fundamental theorem of calculus. We can just use an antiderivative of this function. An antiderivative of this function is going to be, so here we have 1 over 4 times. Antiderivative of this function is going to be 2 over 3 x to the power of 3 over 2. We have to calculate that at 0 and at 4 and subtract. So if I do so, I'm going to get 2 over 12 times. If I plug in 4 into this, I'm going to get 8. If I plug in 0 into this, I'm going to get 0. So the answer is going to be 16 over 12, which can be simplified to 4 over 3. So that's the average value of this function over this interval from 0 to 4. So in case you're curious how I got 8, if I have 4 to the power of 3 over 2, I can write that as 4 to the power of 1 over 2, that to the power of 3. But this is like having root 4 to the power of 3. So 2 to the power of 3, 8. So that's how you calculate 4 to the power of 3 over 2. Any questions? So in the section 6.5, towards the end, there are a few, I think after 27, the 28 to 33. These problems are about the average value of the function. I'm going to do this one for you as another example and then give you the rest of the time to work on the exercises. You want to find the average value of f of x is x to the power of 4 within the interval from 3 to 5. According to the formula, the average value is going to be 1 over b minus a, integral from a to b of f of x dx. So it's going to be 1 over 5 minus 3, integral from 3 to 5 of x to 4 dx. So it's going to be 1 over 2 times. The antiderivative of this is 1 over 5 x to 5 from 3 to 5. So it's going to be 1 over 10. This is 1 over 10. X to the power of 5. 5 to the power of 5 minus, if I plug in 3 to the power of 5. So I'm going to use my calculator to see what 5 to the power of 5 minus 3 to the power of 5 is. Divide that by 10. I'm going to get, or I can actually just enter the fraction. 2882 over 10. Submit the answer, and that's it. Is that clear? About the
Sir, I have a
average
question.
value. Yes.
What is the number under the one? It's -1 under what? Like over what?
Which part are you talking about? So this one,
The
that's
one in the
equation.
middle.
This, I
Yeah.
just, yeah, I wanted to write 3 minus 5. That was wrong. I was supposed to write 5 minus 3, b minus a. So I just crossed it out.
Okay, so it's 5 minus 3.
Yeah, b minus a.
Okay, thank you.